Welcome to our exciting tutorial on using AI for game development. In this video, we'll explore how artificial intelligence enhances game design and improves the overall gaming experience. Whether you're an aspiring game developer or just curious about AI's capabilities, this video is for you. In today's session, we will cover several key aspects, including NPC behavior, procedural content generation, and AI-assisted game testing. We'll also provide code examples to show you how to implement these techniques in Java, so be sure to stick around. Let's start by discussing non-player characters, or NPCs, and how AI can drive their behavior. NPCs are essential for creating immersive game worlds, and AI can make them more lifelike. One of the most common AI techniques for NPC behavior is state machines, which help define how the NPCs respond to different stimuli. Let's create a simple state machine to manage an NPC's actions. In this example, we have an NPC class equipped with a current state that utilizes various states like idle state and attacking state. Each state class defines the unique behaviors for that state. Now, let's see how we can make the NPC react to environmental changes, like detecting an enemy. Here, we define an enemy detected state that transitions the NPC state to attacking when it spots an enemy. With this structure, we are enhancing the intelligence of our NPCs and making our games more engaging. Next up is procedural content generation. This technique allows game developers to create content automatically, saving time and resources while providing players with a unique experience every time they play. Let's build a simple example that generates dungeons using Perlin noise. In the dungeon class, we define a generate dungeon method that would ultimately call upon a Perlin noise function to fill the grid with different values representing walls, corridors, and rooms. This foundational setup enables endless variations of dungeon layouts within the game. To fully realize procedural generation, you will likely need to create or include a library for generating Perlin noise, such as the one provided by Ken Perlin himself. Additionally, the generated grids can be transformed into playable maps by correlating grid values to draw tiles in your game's graphics engine. Another fascinating application of AI in game development is AI-assisted game testing. AI can help optimize the quality assurance process by automatically finding bugs and ensuring games function properly before release. In the IDSTR class, the perform test method outlines a scenario where the AI simulates player actions and reports any bugs encountered during the game's execution. This automates tedious testing processes and can greatly enhance your game's reliability before it reaches players. One interesting approach could involve training a neural network based on player behavior during alpha testing phases, allowing the AI tester to more effectively mimic real players. This gives us not just a better testing phase, but also deep insights into how players interact with our game. With all of this in mind, let's recap what we've learned about using AI in game development. We explored the use of AI for NPC behavior through state machines, procedural content generation for unique game environments, and AI-assisted testing to ensure quality assurance. Of course, this video is just a brief introduction to these concepts. Each topic can be expanded upon extensively, and there are numerous libraries and frameworks available to assist you in integrating these AI techniques into your projects. If you're looking for more in-depth explorations into topics like machine learning for NPCs, advanced procedural algorithms, or complete testing frameworks, let us know in the comments below. We would love to create more content tailored to your interests. Thank you for watching. If you found this tutorial helpful, please give us a like and subscribe to our channel for more exciting content on game development and programming. Until next time, happy coding!